Rồi.
Hello everyone and hello Mr. Tan. Today our group will present about our final project, machine learning for detecting abnormal transactions. Our group had three members, THUY, me and Tú. The content of today will be abstract, project, algorithm, data, model reaction and training, conclusions. And THUY will talk about the abstract of our project.
Using advanced PHAM technologies to commit internet banking fraud involves unauthorized shifting and withdrawal of money from the user's account balance. The concept of fraud often brings credit card fraud to mind, especially given the current scenario. Credit card fraud has significantly increased recently thanks to the rapid growth of credit card purchases. To detect, identify, and prevent such undesirable activities, fraud detection involves monitoring users' purchase behavior. The goal of this project is to employ various machine learning approaches such as logistic regression, random forest, SNN, and INN to predict genuine and fraudulent transactions. The model that exhibits higher score overall will be considered the best fit of the system. Fraud is pervasive and costly issue in sectors like finance, insurance, and e-commerce. Organizations need effective fraud detection systems to protect their assets and maintain trust. Our project aims to develop a machine learning model using credit card fraud dataset to accurately on different differentiate between genuine and fraudulent transactions. By improving fraud detection, business can mitigate risk and safeguard their operations. Credit card fraud detection is a classification problem where model is built using historical credit card transaction data to differentiate between legitimate and fraudulent transactions. The model is trained on significant amount of internal historical data, including both genuine and fraudulent transactions. Data technicals like dimensionality reduction can be used to address class imbalance. Supervised machine learning methods such as decision tree, logistic regression, k-nearest neighbors, SVM, random forest, and XGBoost, as well as unsupervised methods like principal component analysis, k-means clustering, and neural network that are commonly employed for credit card fraud detection. During the training phase, the transaction data is analyzed to extract relevant features and split into training and testing sets. The model learns from historical patterns to predict the likelihood of random transactions. The goal is to achieve high detection rates for fraudulent transactions while minimizing misclassifications of non-fraud transactions. The evaluation of the model's performance is based on two true positives: fraud case predicted as fraud, true negatives, non-fraud cases predicted as non-fraud, false positives, non-fraud case predicted as fraud, and false negatives, fraud case predicted as non-fraud. Overall, the process involves building a model using historical data, training the model to predict fraudulent transactions, and evaluating its performance using various metrics. Here is an image describe this information. In the context of credit card fraud detection, there are many algorithms can be used. However, for this project, the static algorithm are logistic regression, random forest classifier, FCNN, and INN. The first one is logistic regression. Logistic regression is a supervised learning classification approach that predicts the probability of a target variable. It is commonly used to categorize data based on set of if then statements present in a decision tree structure. The algorithm split data into subsets by evaluating significant attributes and maximizing information again. It measures the impurity of resource classes to determine the best splits. Logistic regression is known for its transparency and straightforward application through a series of questions down the decision tree. It's particularly useful for classifying data and predicting probabilities in various applications. The second one is random forest classifier. Random forest is a powerful example learning technique that combines multiple decision trees to enhance classification or regression performance. By aggregating the prediction from multiple trees, it helps to smooth out errors and improve the overall accuracy of the model. Random forest is known for ability to handle unbalanced and missing data efficiently. However, it may struggle to make predictions beyond the range and training data in duration tasks and can override noisy datasets. Ultimately, the performance of random forest, like any algorithm, should be assessed based on this performance on specific dataset at hand. The third one is fully connected neural networks. Uh, are widely employed in credit card fraud detection. They consist of interconnected layers of neurons and can capture intricate patterns and relationships within transaction data. SNN learn from label data to identify fraudulent behavior and make predictions about the likelihood of new transactions being fraudulent. Their ability to uncover complex patterns enhance the accuracy of fraud detection systems. The last one is artificial neural networks. ANN are utilized in credit card fraud detection. ANN mimic the human brain and can learn patterns to identify fraudulent transactions. They analyze transaction data, adjusting their connections through training of optimized fraud detection. INN excel as capturing complex relationships and adapting to changing fraud patterns enhance the effectiveness and fraud detection systems. Uh, then we talk about the comparison of models based on advantages and limitations. The first method is logistic regression. Its advantages include simplicity and interpretability. Uh, the second one is efficient and efficient computation. The last one is works well with learning separable data, but it has its disadvantages. Its advantages including assumes linear relationships between features and target variable, limited, limited ability to capture complex interactions and non-linear relationships, are prone to underfitting if data is not well presented by linear model. The second method is random forest classifier. Ensemble as advantages include ensemble for decision trees improves classification performance, handles high dimensional data and complex relationship, problems to outliers and noise. But its advantages include lack of interpretability compared to individual decision trees, longer training time for large datasets, can overfit noisy datasets if not properly tuned, limited ability to extrapolate beyond the range of training data. The third method is FCNN. Its advantages include ability to capture complex patterns and relationships in data, adaptability to changing fraud patterns, can handle high dimensional and non-land data. Its limitation includes requires a greater amount of training data to avoid overfitting, longer training time, especially for deep networks, are prone to black box behavior and lack of interpretability, sensitive to hyper, hyperparameter tuning. The last method is ironing. Its advantages include flexibility to model complex relationships and non-linear patterns. Robust feature learning capabilities can handle high dimensional data. Adaptability to evolving fraud patterns. Its limitation includes requires substantial computational resources, longer training time, especially for deep architectures, prone to overfitting if not properly regular, regularized. In, inter, interpretability can be challenging due to network complexity.
Hello, I'm Nguyễn, and I will talk about the EDA of the project. The dataset we use is uh, the the predicate. Uh, uh, the project utilized a dataset comprising the transaction history of predicate holder in Europe. The dataset was obtained from September 2013, 2013 and consists of two A4, A07 transactions over a 48-hour period, out of which only 0.172% are fraud and the rest of the dataset are genuine. This dataset was widely used in many papers as shown below. As you can see, the dataset is pretty imbalanced and it contains only numeric values. The time and the male column are not transformed. The class column was served to respond a variable indicating 0 for genuine and non-fraudulent transactions and 1 for fraudulent transactions. Additionally, there are no known values in the entire dataset. The dataset will be divided into a training set and a test set with the 80% of the data allocated to the training set and 20% to the test set. The model is constructed using four different machine learning approaches. The approach that achieves the highest accuracy, recall score, precision score, and F1 score will be considered the best fit for this problem. For each input variable, a histogram is constructed to show its distribution. Next part, we will talk about model creation and training. Firstly, we train all logistic regression. First, the data is loaded initially with the assistance of the bandage collections. The dataset is split in the next step into value of x and y, and size of both values are written. To carry out the produce of the training and testing, the method named train plastic is used. After distributing the data into train and test sets, the regression algorithm is implemented. Uh, Then the objective function of objective is defined for optimized. It optimizes hyperparameters C and match Easter to create a logistic regression model. The model is trained on the training data and the currency evaluated on the test set. This we create an optimized study, and the hyperparameter optimization process is skilled for the specified number of trials. In this case, it is 3, and the best hyperparameter found by Alternate are printed. Subsequently, the best model is iterated using the best hyperparameter, and is trained on the training data version are made on the test set using this model. The code then calculates various evaluation metrics involving accuracy, precision, recall, and F1 score using a progress function from scalar metrics. And you can see the accuracy here is 0.9992, precision is 0.80327, and recall is 0.5, F1 score is 0.6163. Uh, And this is our random forest classifier models. The data are also utilized by the Bandit library, and the trend test split method were used. We processing the data and define the objective function for the optimal study. After that, we train the random forest model using the best hypermeters. This approach gives us an accuracy of 99.957%. And lastly, the confusion matrix iterated for this approach utilizing the confusion matrix methodologies. It is shown below. Next, two will talk about FCNN models.
Hello, teacher. I am Cẩm Tú, and I'm going to talk about fully connected neural network. The code split the data into feature X and the target variable Y using train splits from scikit-learn. It's the apply min max scaling to standardize the feature between 0 and 1. The objective function is defined for hyperparameter optimizations using optional. It has a trial object input, which represents a single evaluation of the objective function with a set of hyperparameters. The function defines the search space for the hyperparameters, creates a fully connected neural network model with the suggested hyperparameters and trains the model on the training data. The accuracy is calculated as the evaluations metric and returned to optimal for optimizations. This feature is no. Chưa. This feature is about defining the objective function for optimal. The code sets up the optimal study and runs the hyperparameter optimization using the study optimized functions. After the optimization process, the best hyperparameters are obtained from study best params and printed. The next is The best hyperparameters obtained from the optimization are used to create a new fully connected neural network model with, with the best architecture. Then the model is compiled with the item optimizer and trained on the entire training data with the fit method. Um, this next. Oh, we will create FC in English optional and then release labels for the test set using FC in English optional and can create evaluation metrics. This approach gives an accuracy of 99.939%. Ê, cái đó xong rồi. And lastly, the confusion matrix is created for this approach utilizing confusion matrix methodology. It is so like this. And the next is artificial neural network. The code split the data into feature X and the target variable while using train state split from scikit-learn. It also applies min-max scaling to the data using min-max scaler to ensure that all features are within the same range. The objective function is defined for hyperparameter optimization using optional. It takes a trial object as input, which represents a single evaluation of the objective function with a set of hyperparameters. The function defines the search space for the hyperparameter, create an INN model with the suggest hyperparameter and train the model on the training data. The accuracy is calculated at the evaluation matrix and returned to optimal for optimizations. After the optimization process, the best hyperparameters are obtained from study best params and a new INN model. Best model is created with the best hyperparameters and it is trained on the entire training data. The first feature is is create a optimal study. And the second is create the best model. Okay, this approach this this when this approach is this approach is an accuracy of 99.946%. And lastly, the confusion matrix is created for this approach utilizing confusion matrix methodology. It is so as below. Um, this table is show us the comparison of machine learning approach. First, the first four columns is about the confusion matrix, and the misclassification rate is equal one sub accuracies. And the next is precision, recurrence, and F1 score. Conclusion. I will talk about the conclusion. The results clearly demonstrate that machine learning is well suited for credit card fraud predictions. As for the experimental results, it has been observed that the accuracy is maximum for random forest classifier followed by INN. The misclassification and error rate is minimum random forest classifiers followed by INN. The value of sensitivity and recurrence is maximum for random forest classifier as well as INN. Precision is maximum for random forest classifiers followed by INN. F1 score is maximum for random forest classifiers followed by INN. Type 2 error prediction legitimate non-robust actual fraudulent, which is a serious one, is minimum for random forest classifier followed by INN. Based on the observations, random forest classifier comes out to be the best overall algorithm as per the current result analysis. In addition to classification problems, machine learning algorithm aim to minimize misclassifications by using metrics like accuracy and F1 score to measure model performance. However, in certain cases, it may be more preferable to accept some misclassification in exchange for lower overall cost. When the cost of misclassification vary across sample, a cost-sensitive example-dependent learning techniques can be employed by inco- incorporating misclassification costs for, for false negatives, called FN, and false positives, called FP. We can customize the model to better suit specific cost considerations. A cost function will be used to evaluate the machine learning model performance with the given data. This function measure the discrepancy between projected and expected value, enabling us to assess the model's prediction accuracy. By minimizing the cost functions, we can fine-tune the model and improve its predictive capability. After experimenting with various algorithms, including both deep learning such as artificial neural network (ANN) and machine learning such as random forest, we discover that for straightforward classification tasks which create relationship between input and output data, machine learning specifically random forest tends to be the optimal choice. On the other hand, for more complex problems that involve higher requirements and intricate data processing, deep learning, particularly ANN, emerges as the most suitable option. This is due to the flexibility and adaptability of ANN in handling complex patterns and non-linear linear relationship within the data, while machine learning algorithm like random forest excel in similar classification scenarios. Deep learning techniques such as ANN are better suited to tackle intricate problems that demand more advanced data processing capabilities. In case of redundant transactions classification problem, we will choose random forest among the three algorithms to get the most optimal result. And after that, when we'll talk about dashboard, the dashboard.
I will give you the overview of the our dashboard. First, our dashboard is the first one is the random forest prediction on our test sets, and the total transaction is around up to uh, 56 uh 56,000 the transaction, and our model have lasted about seven 75 lattice transactions. The max amount of lattice transaction in here, the average and the mean amount by zero. The fraud distribution is this one, and uh, you can search by ID to see if our model have predicted the ID transaction to be fraud or non-fraud. You can explore the brand here, and the entire dashboard will update for you. This is our uh, important by features. This is our dataset have V1 to V28 columns, but all that is zero button it's so in the historical diagram that uh it's on hit on characteristic and will not take any strong uh efficient of the models, and this is our fraud and non-fraud transaction by time. You can uh, analyze the drain of the fraud. This is predicted fraud, and this is predicted a non-fraud. And this one is fraud and non-fraud transaction by amount. You can predict it. You can analyze the amount and drain of predicted fraud. And you can see that the fraud it will not have a lot of transaction, like the amount will not very high. You can and the other dashboard is our random forest prediction on test set compared with the actual label. The predicted fraud we have flash is 75 and the actual one is 98. The this kind this system right here kind of like a confusion matrix. You can see that the non-fraud and actual non-fraud is 56862, and it's not fraud but predicted a fraud is 2, and the actual fraud but predicted a not fraud is 26, and the actual fraud but predicted a fraud is 72. The predicted fraud and the fraud amount by amount and actual fraud and predicted fraud by time, you can see it kind of similar because our model had the high accuracy of 0.999, and this is the precision scores. This is F1 score, and this is a recon score. You can search by ID to compare the actual to the table, a predicted label and the actual label. I will check about the ID 5. This rated label is non-fraud and the actual label is non-fraud. That's it at the end of our presentation. Thank you for listening, and this is our reference. Thank you for listening.